Good afternoon, ladies and gentlemen. Today, I would like to talk to you about the ocean. The ocean that we all know, the ocean that we all love, and the ocean that, through our actions, is becoming endangered. Not just the ocean, but the life that lives there, and that we may be losing at a very fast rate. So what's the trouble with the oceans, and what are we doing concerning that? If all the world were paper and all the sea were ink, if all the trees were bread and cheese, what would we do for a drink? This is just from a child's bedtime song, but it tells you how important oceans are for us. And water is the most, together with air, is the most important component of Earth. Oceans occupy over 70% of Earth's surface and hold over 95% of all the water that exists in the world. And we just had a very nice talk about water. And we know how important it is, water. Oceans were the birthplace of life. Oceans today hold, at least we know about, over 230,000 species, and we think that there may be 2 million or more. Oceans produced, not oceans, but tiny organisms that live in the oceans, produced most of the oxygen that we breathe, and today they continue keeping that supply going on. And we all know that without that, life on Earth wouldn't be possible. Oceans regulate our climates. You know, if you live near the sea or the ocean, you see that the climate is more moderate. You don't have, so cold winters or so hot summers. But also, waters of the ocean carry from the tropics heat towards colder regions. For example, the Gulf Stream on the northern Atlantic, we consider that the heat carried by the Gulf Stream from the polar area, from the tropical areas towards the polar areas are probably one of the responsibles for the development of our civilization. And of course, economy. We all love nature, but we usually think more about ourselves. That's okay. So oceans are transportation means, oceans are communication means, oceans are sources of food. Indeed, 1 out of 7 people that live on the world would not be able to live without the sources we collect from the ocean. Now, what's going on with the oceans? I told you at the beginning they are being troubled, endangered by our actions. I'm using a very simple model so we all understand. Oceans are becoming like vinegar. And we all know what is vinegar. We use it in our kitchens for sauces and things like that. How is it happening? CO2, we all have heard about CO2, we read about CO2 on newspapers, and we see that on TV and radio. CO2 is going out from our cars, our houses, our industries, our planes, our ships, and accumulates in the atmosphere. Then dissolves in the water of the ocean, and by combining with that water, becomes an acid, becomes the so-called carbonic acid. And this acid is acting with carbonate. Our bones, for example, are made of calcium carbonate. Most of bones, shells of the animals, spines of sea urchins, etc., are made of calcium carbonate. So this acts with it and starts dissolving. Let's just give you a little example of what is happening to the animals in the sea. Maybe some of you did it at school. I did it when I was your age. But if you didn't, you can get home and do it. Just use some of the vinegar you have it on a glass, for example, and drop some eggshell. You can also do that with a small bone. And we'll see, if you leave it for a certain time on the vinegar, you see that the eggshell starts to become very fragile. If you could see it under the microscope, you'll see that small holes appear on it. And step by step, those small holes increase. And with time, the eggshell will just dissolve in the vinegar. Exactly the same is happening with animal bones and spines and skeletons and shells in the ocean. Now, is science doing something about it? Is society and governments doing something about it? We first knew about it, when I talk about we, I mean science, around the year 2000 when, because of the CO2 accumulating in the atmosphere, governments were thinking of, well, maybe we can just dump it into the ocean and get rid of it. And then scientists started doing experiments. They started enriching seawater in laboratories with CO2 and looking what happened to those animals and plants that lived in there. And they noticed that skeletons started to dissolve, reproduction started to, be late or be stopped even, growth started to decrease. And that's when all of this question about the so-called ocean acidification started to come on. People like me, here at Hokkaido and in many other places, we work with sea animals. In this case, it's bryozoan, kokemushi in Japanese. It's an animal, a colony, that looks like a plant, as you see there. It has a skeleton made out of calcium carbonate, exactly like my skeleton, exactly like your skeleton, exactly like the eggshell. So what I do is that I put these animals in the lab, in bottles enriched with CO2, and I see what happens. What happens to their growth? And what happens to their growth is that with time, growth decreases and even stops. And what about the skeleton? Well, the above picture is a normal skeleton. And you look at what happens to the below picture. Skeleton starts to dissolve. But reproduction also stops in many cases, and physiology and a few others. These are just the more evident results that we are obtaining. The other thing that we do is that we use collections. Whenever you go to a museum and you see a beautiful exhibit there, think that that material of the exhibit is used by scientists to compare what was before, because those collections maybe have 100 years or 200 years, sometimes more. So you can compare those animals, those plants with what you have today. And you can see those changes happening. Let's talk a little about Japan. We are here in Sapporo, beautiful city. Well, Japanese waters, oceans surrounding Japanese islands, hold almost 15% of all the diversity in the oceans. This makes up a little over of 33,000 species that are here. So it's a big responsibility. Now, is Japanese society, Japanese government doing something about ocean acidification? Yes, it is. Quite a lot, as a matter of fact. One of the things that you can have access to it and you can see the state of the art, so to speak, of ocean acidification. It's this Japanese Meteorological Society website, which records all the progress of ocean acidification, not just surrounding Japan, but also in other parts of the world. Graphs like this, for example, you can see there. For example, you see that one way we measure ocean acidification is through the so-called pH. And pH varies between 1 and 14, being that 1 is the most acidic and 14 is not acidic at all. So if you look there, you have the pH, and you have years from 1980 through 2010. And you see those graphs, you see how pH is decreasing, which means if pH is decreasing, acidity is increasing. Remember, as low pH, as higher acidity. And then on your left side, you have also a transect of the Kii Peninsula. In the Kii Peninsula, on the last 26 years of measurements, we noticed that acidification had increased by 0.04. Well, you say, well, 0.04 is nothing. It is something, because during the last 200 years, acidity increased by 0.1. Now, make the math, make the calculations. 200 years, 0.1. 26 years, 0.04. In the next 200 years, the acidification will be much higher than had been on the last 200 years. And that's one of the biggest problems, is the speed at which it goes. And that's why we think, and we are sure, as a matter of fact, that it's human action that is doing that. That's exactly. Another program that the Japanese government has and that I'm working on and is several projects, big projects, working on animals and plants, and also developing tools. We need better tools in order to know better what is going on in the ocean. Searching for solutions. The Kyoto Protocol, I'm sure you all heard of it. It went in action in 2005. It will expire this year, and there is no replacement. Governments in the world had not become to a solution to replace the Kyoto Protocol. Well, maybe Japanese society, that was one of the initiatives of the Kyoto Protocol, maybe can take the lead, and maybe should take the lead about this. And it's really important to have a replacement. Now, what about us? You know, the ones that are here, the ones that will maybe listen to this, or are, you know, noticing about through Twitter and other mechanisms. Can we do something? Yes, we can. We can always do something. First of all, we can use better the resources of the ocean. Second, maybe we can use bikes and walk instead of using the car, so it has less CO2 going to the atmosphere. Maybe we can heat a little less our houses. You know, I also like to be comfortable at home. But still, think about all the CO2. Think that we are the future, and the ocean is here, was here, and we want it to be continuing here for the future generations. If we want to save it, all of us need to have our little grain of sand in order to have a big beach. In this case, a little drop of water in order to have a healthy ocean and all the life that lives in it. Thank you.